This is video number 3 for 7.3. These are just a few examples of your homework, being that the other two videos had some examples of the other types of homework problems that you're going to be doing. I'm only going to do 4 of these. We're going to do problems like at number 11, 12, 16, and 18. So this should be a short video. One of the brightest stars in the sky is Alpha Centauri, which is part of the constellation Centaur. Alpha Centauri is 4 light years from the Earth. 1 light year equals 5.88 times 10 to the 12th miles. How far in miles is Alpha Centauri? So we're going to take the number of light years, 4, and multiply it times what 1 light year equals, which is 5.88 times 10 to the 12th. Now do not do the distributive property here. This is only distributive property is used when this symbol is a plus sign or a minus sign. That's a multiplication sign. So what we're going to do is we're just multiplying the 4 and the 5.88. You can even think of it like this. This is 4 times 5.88 times 10 to the 12th. Okay? I don't really like it that way, so I'm not going to use that, but that's what we're doing. We're just multiplying the 4 times the 5.88, and that is, you can use your calculator, 23.52 times 10 to the 12th. Now, this number is bigger than 10, so that means I need to move the decimal. I'm going to move my decimal to the left. Remember, when you go to the left, that's adding. Go to the right, that's subtracting. So I went to the left once. That means I'm going to add 1 to the 12 in the exponent part. So this is 2.352, don't round, times 10 to the 13th. And I know not to round because it says right here, do not round. So the answer is 2.352 times 10 to the 13th miles from Earth. So that's how you do number 11. Number 12, and I guess I have number 13 on here too, so I'll go ahead and do that. Number 12, what we're doing is, since we're multiplying and the bases are the same, then that means we're taking the exponents. The first exponent is 4, plus the second exponent, I'm just going to put an X there. And we're making an equation out of it. We're adding the exponents on the left side to equal the exponent on the right side. So this is an equation, if you will. So we're going to subtract 4. So the variable, the exponent, the box where we put an X, that should be a 3. Same thing on number 13. So where this box is, I'm just going to put an X. So I'm adding the exponents because all the bases are the same. X plus negative 3 equals negative 12. You want to rewrite that to be x minus 3, because plus a negative is just one minus sign. And add 3 to both sides. And so the missing exponent where the box is should be negative 9. Okay. All right, number 16. Remember, when we have same bases, doesn't matter where they are, the bases are the same, we're adding the exponent. So we're going to add the exponent 3 plus the exponent negative 5, and so that will keep the base the same, be a to the negative 2. So 1 over a to the negative 2. It says use positive exponents only, so that means I'm going to flip it with a 1, and so it's a squared over 1, which is just a squared simplified. Okay, and last one, number 18, looks a little complicated, but it's not that bad. Remember, if it has an exponent, then that's considered a base. So y plus 5 is a base here and a base here. So the bases are the same, so I'm just going to add the exponent. 7 plus negative 5, that equals positive 2. So keep the base the same, and we're going to write it as y plus 5 to the second power. And that's all they're wanting you to do there. All right, now you're ready to do the homework problems.